I'm Anil Kumar. Welcome to my series on similar triangles. We'll first try to understand basic concepts about similar triangle and then take up 10 examples to understand it in details. When we say similar triangles, we are trying to look into triangles where two angles are similar for two different triangles. So let me make triangles here. For example, if this is one of the triangles, and if we enlarge it a bit, make a bigger one, so that their corresponding angles are equal, then we say that triangles are similar. When we say corresponding angles, means there should be a set of angles like this angle equal to that angle, and let's say some angle like this equal to the other angle. So we can now say that triangle, let's say ABC, is similar to triangle DEF. And we write it like this. Triangle ABC is similar, that is the sign for similar, to triangle DEF. Why are they similar? Because of the property we say AA property. So AA similarity. Now two angles are enough to look into because third will automatically be equal, right? So this third angle will always be equal if two are equal, since sum of three angles is 180, correct? So that is how we basically understand similar triangles. Now whenever two given triangles are similar, in that case ratio of the corresponding sides are equal. That is to say that AB over DE will always be equal to BC over EF, and that will be equal to CA over FT. So this will always be some constant K. Now this particular corresponding, we call them corresponding sides. Ratio is always constant and equal. This is about similar triangles. Now, this particular property helps us to solve many given situations in real life also. We'll take a few examples. For example, by finding the shadow, we can find height of the building. Now, a few other things which you may require to recall is sides are proportionally, we can say one is sides are proportional. Right, this is one part. What I really mean to say here is, let's say if we have sides of this triangle as, let's say 4, 5, and let's say 7. In that case, and if we know one of the sides of the other triangle as, let's say, let's make things simpler, just doubling them up. So if I say this is 8, in this case, it is K is 2, right? So it's getting multiplied by 2. So the other sides will be twice. So it'll be like 10 and 14. You get an idea, right? So that is what we mean, that the ratio of the sides is constant. So in this case, you can see it is 2. So sides are proportional. So that means we always have a scale factor. And we are calling this as K in this particular example. Here, if I write 4, 5, 7, 8, 10, 14, the scale factor is 2. Right. What else? How about the perimeter? So perimeter is also proportional. That is to say that in this particular case, if the ratio of one triangle to the other is k, then the perimeter will be also times k, right? Now how about area? So area in similar triangles will be in the ratio of what? Now area basically means half base times height. Now each side has a factor of k, therefore the ratio here will be not just k but k square, because there are two sides involved. So as far as the area goes, it becomes k square times. So I hope this concept is clear, right? Now, well, based on this learning, we'll now take up 10 questions, practice our learnings. If you have doubts, feel free to write as in your comments, and I'll always be more than happy to answer all your questions. So let's take up these 10 questions one by one. Here is question number 1. A circle with radius 10 centimeter and a circle with diameter of 10 centimeter are similar. True or false? Justify your answer. So we have two circles. One seems to be bigger than the other. So what you notice here is that the radius of the bigger circle is 10 and that of the smaller circle is 5. The question is, are they similar or not? Now it's important to understand that when we say similar means there is a scale factor. Perfect. So again, here is a scale factor of 2, right? The one with radius of 10 is twice as big as the smaller one. So whenever the shapes are similar, they could be of any shape. If they have a scale factor, in that case we say yes, they are similar. So the answer here is yes, they are similar. This question has been placed here specifically because sometimes students think we only talk about similar triangles. Well, this concept is extended for all kinds of shapes. For example, all squares will be similar. Perfect. They have the same, all four sides, so there will be a scale factor when we pick up one square or the other, right? All circles will be similar for that reason. Okay. Question number 2. Triangle ABC is similar to triangle PQR. So we have two triangles. If the ratio of their corresponding sides is 3/5, what is the ratio of their perimeter? So the ratio of sides is given to us. What is going to be the ratio of perimeter? This is what you need to answer. You can actually pause the video, answer these questions, and then look into my suggestions. So the ratio of perimeter is also going to be same, that is 3/5, correct? Since perimeter is just sum of sides, right? So if we have a triangle PQR whose sides and ABC, so ABC is similar to PQR, the ratio of their corresponding sides is 3/5. Let's say the sides are, perimeter will be A plus B plus C. The other one will be 3/5 times A plus B plus C, right? So that is how their perimeters are related. So the ratio is 3/5. Got it? Question number 3. A triangle has area of 160 meters square. A similar triangle is drawn using a scale factor of 1/4. So if we use a scale factor of 1/4, we are drawing a smaller triangle, right? So let's say this is one triangle. The other triangle with scale factor of 1/4 will be kind of like this. If the area of the bigger is 160 meters square, we need to find what is the area of the smaller one. So what is the area of this one? Well, as far as the area is concerned, it has to be in the scale of square of 1 over 4. So this is going to be 160 times 1 over 4 square. You get the idea. So this is going to be equal to 160 divided by 16, which is 10 meters square. So whenever we are talking about area, the scale factor is k square times. Do you understand? So that is a reminder. When we talk about perimeter, the ratio is the same. So k is our scale factor. Perfect. Let's move on to question number 4 now. In triangle UTV, side UT is 3, UV is 4, so and TV is 6. So the other triangle, okay, in triangle XYW, XY is 16, so that is a bigger triangle. So let me draw these two triangles here in the limited space we have, and then we'll talk further about solving this question. Okay. So we have a triangle, let's call it UTV. So in triangle UTV, side UT is 3, U to V is 4, and TV is 6. In triangle XYW, XY is 16. The two triangles are similar, so they are similar triangles such that angle X is equal to angle U, so these two angles are equal. Angle Y is equal to angle V, so angle Y, this angle Y is equal to angle V. Do you see that part? So these two angles are equal. Find the length XW. So we have to find this particular length, XW. Correct? So that is the question for you. You can pause the video and answer this question. So when we say corresponding sides, look into corresponding sides. Ratio. And then solve. Okay? Now, we are given this side as 16, which is opposite to the angle, the third angle. So what we can do here is we can write 16 over this side, third side, right? So side opposite to the third one is 4. Do you see that? 16 over 4 should be equal to this question mark, which we don't know, over this side is opposite to that angle, y. Right, so y is equal to v, so it is 3. Do you see that? So 3. So that is how you are going to solve it. The scale factor here is 16 divided by 4 as 4, and therefore you get your solution that this unknown side is equals to 4 times 3, right? Or 12. So this side here is 12. Is that clear to you? Perfect. So that is how you should be solving it. So just cross multiply and solve. Question number 5. A right triangle has hypotenuse measuring 13 centimeters and area of 30 centimeters square. Okay, so let me just make a right triangle here. So a right triangle has hypotenuse of 13 centimeters and an area of 30 centimeters square. A similar triangle has an area of 120 centimeters. So the other triangle has area of 120 centimeters square. What is the hypotenuse of the larger triangle? Now, so what is the ratio? So when we talk about area ratios, let's call this as a second triangle, A2, A1. So the ratio will be 120 divided by 30, which is equal to 4. So ratio of area is 4. That means what? That means that ratio of side will be equals to square root of 4, which is 2. So the sides of the bigger triangle will be twice. So what is the hypotenuse? We need to find the hypotenuse of the second triangle. So it will be 2 times 13, which is 26 centimeters. Is that clear to you? Correct? So that is how you're going to solve it. So in very short steps, I've tried to show you the solution. We are not really explaining the concepts. So to understand all these basic concepts, you can look into the links which I have provided where we are talking about basics about similar triangles. Treat this part as a test question, right? So I hope that helps. So let's move on and take up the next 5 questions on similar triangles. Here is question number 6 for you. A flagpole at a school is 10 meter high and casts a shadow of 4 meter long. If the school building is 28 meter tall, how long is its shadow? Right. So we have a school building which is much more taller than the pole. So the shadow will be kind of like this. The flagpole here is kind of situation is like this, whose shadow we could draw as a right triangle shown here. So in these two cases, both will form the right triangle, and since the shadow is caused by the sun, the angle here at the top is going to be same for both. So that means these two triangles are similar. So we are given here that the flagpole is 10 meters high and the shadow is 4 meters. We need to find height of the building, let it be h, but we know that its shadow is 28 meters. So from similar triangles, their corresponding sides should have the same ratio. Therefore, h over 28 should be equal to 10 over 4. So we can cross multiply and find the height. So h will be equals to 10 over 4 times 28, which gives us 7 times 10 as 70 meters. Correct? So as you have seen here, sometimes what we do is we also write ratios as I have written in this case. Perfect. But normally you should write like this: h over 10 equals to, these are the corresponding sides, right? And 28 over 4. Correct? So even then, when you multiply, you get the same result. So h is 10 times 28 divided by 4. But this is a preferred way of writing. You could do this way also. Okay. Question number 7. If two isosceles triangles have one pair of equal angles, are they similar? Now, you have to justify your answer. To explain this situation, let me take an example here, right? So let's take an example here. Let's take one triangle. Let's give some numbers. Let's say similar means, isosceles triangle. That means two sides are equal, right? So let's say these two sides are equal and we have 40 degrees and 40 degrees angle. So the third angle has to be 100 degrees. Now, let us say in this situation, we know one pair is equal. So in that case, let's say we have this pair as equal. Let's say we have this pair as equal, 40 degrees. Now, in this case, are we always going to have similar triangle or not? That is the question. So, think about it like this. We know that one pair is equal, right? So we have a case when one pair is equal. So this is 40 degrees. Is that okay? Now, there could be two different situations. In the given original triangle, so this is given to us, right? We have 40 and 40 combination. Perfect? But think like this. We could have a similar situation like this where the other is also 40 degrees and that becomes similar. However, we could have another triangle where it may not be similar. Think like this: 180 minus 40 is 140. And if I divide this by 2, I get 70 degrees and 70 degrees, right? So, if I have another triangle whose angles are not 40-40 each, but on the other hand, they are kind of like this. So that is to say, I have this triangle isosceles again, but these angles are both 70 degrees. That is possible. You understand? So that is not similar. You get an idea. So in this case, the statement is not always true, right? So it is not always true. So if I say, if two isosceles triangles have one pair of equal sides, they are similar, the statement is incorrect. So it is wrong. So it is false. Do you understand how? So we have provided an example where it is not similar, and therefore the statement is incorrect. So I hope this statement is absolutely clear. So very important question. Now let's take up the last three examples. Now here is another very interesting question on similar triangles. You can actually take a break, try to solve this question, and then get back to my solutions. Question number 8. Anil is making a scale drawing of his flower garden, which is shaped like a right triangle with hypotenuse of 12.5 meters. What is the scale factor of Anil's drawing if the two legs of the triangle are 7 centimeter and 24 centimeter in the drawing? So that is the first part. And the second part of this question is, what is the area of the actual garden? Okay, so let's make approximate sketches for the actual garden, which is much bigger. So make a note that the dimensions are given in meters for the actual garden, which is 12.5 meters, right? So at times, students may just miss on the units and provide wrong solution. Here is the actual drawing. Dimensions for the actual drawing are 7 and 24 centimeters. Let's keep this as 24 centimeters and this is 7 centimeters. So both are right triangles. So now I hope the situation is absolutely clear. What you need to do is, what is the scale factor of Anil's drawing? That is first thing which we need to find. Okay. So to find the scale factor, we know the hypotenuse of the bigger triangle, the actual one. Let's find the hypotenuse of this. So let's call this as C, the side C. So C for us is equal to square root of 24 square plus 7 square. Now these dimensions are very interesting. If you know the Pythagorean triples, you will know that C should be 25. Correct. Good number to remember, this combination, right? But we'll just use calculator to verify. So we do square root of 24 square plus 7 square equals to, it gives you 25. Correct? So just as you remember 3, 4, 5 are sides of right triangle, 7, 24 and 25 are also sides of right triangle. Okay, so we know what C is. C is in centimeters. So now let's find the scale factor. So the scale factor is, let's write the bigger side on the top, which is 12.5 meters divided by 25 centimeters, right? So this is meters. You have to multiply by 100 to really get the correct answer, right? So this is 1250 divided by 25. Now both are in centimeters, correct? So when you divide, what do you get? Okay, so let's divide and find our answer. So we get 1250 divided by 25. So that gives you 50 as your answer. So the scale factor is 50. Correct? Each side will be multiplied by 50 times. Correct? In a way, 100 by 2. So converting to meters, right? So that is to say, this will be in meters and then half of it, correct? So that is how you're going to get it. So it should be, you can say 12 meters and this will be 3.5 meters. So those will be the actual dimensions. Well, no one is asking for that, but anyway, we got the scale factor. Now, second part to this question is, what is the area of actual garden? We need to find area of this garden. How do you find it? Well, one way you can find the sides and then get it. The second way is, area will be 50 square times area of diagram. You get the idea, right? So area will be 50 square times. So the area, the bigger area, is going to be, what is the area of this smaller triangle? The smaller triangle, the drawing is half of 24, the base, times 7. And we have to multiply this by 50 square. And the units will be centimeters square. You get an idea. So that is how you're going to find the area of the garden, the actual area. So let's find it. So we have 24 times 7 times 50 square, and we are going to divide this by 2. So it gives us a very big number, 21 and 4 zeros. This is in centimeters square. It's a good practice to write this answer in meters square. So this will be equals to 21, 4 zeros, 1, 2, 3, 4, divided by, this is in centimeters square, correct? To write it in meters square, what should you do? We know 1 meter square is equal to 100 centimeters times 100 centimeters. Correct? So these 4 zeros will cancel. So you get 21 meters square. So the area of the actual garden is 21 meters square. Is that clear to you? Now, why I have taken this time to solve, so that you understand how to solve these questions, convert units. Now, what you can do is verify using these dimensions. Do you see that? Half of this should give you 21. That's the whole idea. So we can verify now. So we get 12 times 3.5 divided by 2 equals to 21. Perfect. So that is how you could verify also. So I hope all the steps are absolutely clear. Now let's take up the last two questions. We are almost at the end. Here is question number 9. Find the unknown sides to one decimal place. So let me label this triangle as triangle ABC. Let's call this as P and Q. We need to find what is X and what is Y. You can always pause the video, answer the question, and then look into my suggestions. Now looking into these triangles, what do you get? Can you find two similar triangles? Well, let's look into a bigger triangle ABC and a smaller triangle PQB. What you notice is that the side angle A is equal to Q, so that is equal to Q. Then the other angle C is equal to angle P. We're talking about ABC. B is common. Okay, so B and P is equal to C. So since these two sets of angles are equal, these two triangles are similar. Do you see that? Since we know that angle A is equal to angle Q, right? And we are also given that angle P is equal to angle C. So from the property of double A, obviously the third angle has to be equal. In this case, the third angle is actually common, right? So definitely they are two similar triangles. When they are similar triangles, we should write ratio of their sides, corresponding sides. So for bigger triangle, let's take the side CB, and this CB corresponds to which side? So we're looking at a side which is opposite to angle A in the big triangle. So in smaller triangle, it will be 30, correct? Which is side PB, right? That should be equal to, let's take the third side, which is, let's say, CA, right? So CA should be equal to which? Now CA is opposite to B. So what we notice here is that CA is opposite to side B, correct? So in smaller triangle, it is Y, which is PQ. So we'll write this as PQ. So I hope you understand how we are matching the corresponding sides. It's kind of tricky in such diagrams. Now AB is the third side for the bigger triangle. AB is opposite to this angle, perfect, which is this angle. So this is side AB. In smaller triangle, it should be PQB, right? So that is over QB. So these corresponding sides have same ratio. Now let's write down the values known. C to B is 26 plus 24. P to B is 30. That should be equal to C to A, which is 32. PQ is Y. A to B is X plus 30. And Q to B is 24. So that gives you set of equations which can be solved to find X and Y. Clear? Now 26 plus 24 over 30 is kind of 50 over 30, correct? Which you could simplify and write as 5 over 3. So I'm writing 50 over 3, 5, which is same as 5 over 3. Is that okay? So we get two sets of equation. One, let me write down here the two sets of equations which we get. One, which is 5 over 3 is equal to 32 over Y, and here we get 5 over 3 as equal to X plus 30 over 24. Is that clear? So cross multiply, Y equals to, so Y comes here. So you could write this as 5Y equals to 32 times 3, or Y is equals to 32 times 3 divided by 5. Or you could have written directly. So we can now find the value of Y, which is 32 times 3 divided by 5 equals to, in decimals, 19.2. Correct? So we get 19.2 centimeters as Y. Now let's find X. We'll just cross multiply again. So we get 5 times 24 equals to 3 times X plus 30. So 5 times 24, 5 times 4 is 20. 5 times 2 should be 120 equals to 3x plus 90, right? So let's simplify. 120 minus 90 equals to 3x. So that is 30 equals to 3x, or 30 divided by 3 equals to x, which is 10. So we get x as equals to 10.0 centimeters. Is that correct? So that is how you can find the unknown sides. I'd like you to go through these steps once again. It's kind of critical to match the corresponding sides and then write down the ratios as we did, right? So our answer here is x equals to 10.0 centimeters and y equals to 19.2 centimeters. Now let's move on and take the last question. Here is the last question. I hope you are enjoying this journey and you have learned while answering these 10 questions. Question number 10. Find the unknown sides to one decimal place. You can always pause the video, answer, and then look into my suggestions. Now here also, from the property of two angles being same, we can say that triangle ABC, the bigger triangle, is similar to which triangle? ABC. So we'll maintain the order DEC. Correct? So if these two are similar triangles, then their corresponding sides should also be in the same ratio. So we'll write CB. So this big side, which is opposite that angle, should be equal to by CE, right? Okay. Now 20, which is AB, over DE. And the third side is AC over DC. So that gives you this set of equations. So let's write down the values given to us. CB, C to B is 6 plus 8. So we can write 6 plus 8 over CE, C2 is 6, equals to AB, which is 20, over Y, and that should be equal to AC, which is X plus 9, over 9. Correct? So from here we get two equations to solve, just as we did last time. So 6 plus 8 over 6, let's write down this as 14 over 6. Right? There's no harm in simplifying. You can write 7 over 3 also. So you can write this as dividing both by 2, we get 7 over 3. Is that okay? So that is how you could simplify and then continue. So basically one equation is 7 over 3 equals to 20 over y. The other equation is x plus 9 over 9 equals to 7 over 3. Is that okay? Now cross multiply. So we get y equals to 20 times, you could do 3 over 7 and get your answer. So we have 60 divided by 7 equals to, in decimals, 8.57, which is rounded to one decimal place as 8.6 units or centimeters. Is that clear? Let's cross multiply here. We get 3x plus 3 times 9, 27, equals to 9 times 7, 63. So I just cross multiplied. So basically I multiplied both of them with 3. So 3x, 3 times 9 is 27, and then cross multiplied 9 with 7 to get 63. So 3x equals to 63 minus 27. X equals to 63 minus 27 divided by 3. So we'll do numerator 63 minus 27 first, and then divide it by 3 and find the decimal value, so which gives us 12. So we'll write this as 12.0 centimeters, since we need to write answer to one decimal place, correct? So we got the side as 12 centimeters, the other one as 8.6. So our answer is x equals to 8.6 centimeters, y equals to 8.6 centimeters and x equals to 12.0 centimeters. So this is 12.0 centimeter and y is 8.6 centimeters. Correct? So that is how we are going to actually solve this question. Now I hope you liked the journey and learned a lot about similar triangles. Feel free to post questions, and if you like and subscribe to my videos, that would be great. Also, share my videos with your friends. Thanks for watching and all the best.